Hello everyone, this is Saite Jokla. We are Sebastian and Abu Tahir and Salman. Today we are excited to discuss a critical issue facing in our world, how to create a smarter cities for the sustainable futures, ultimately enhancing urban well-being. As our cities grow at an unprecedented rate, they face a convergence of complex challenges. Uh, like rapid urbanization strains our vital resources, often leading to a decline in environmental quality, such as like air we breathe. It also complicates our ability to respond effectively to crisis, whether they are natural disasters or public health emergencies. These interconnected pressures directly impact the quality of life and the health of millions of urban developers globally. And a challenge we aim to address by aligning with global goals like UN SDG 11. For instance, according to the World Health Organization, like ambient air pollution was responsible for and more than estimated around for more than 4.2 million parameters deaths worldwide in back in 2016. This isn't just an abstract problem. It's a daily reality that demands innovative solutions. Our report and poster focus how we can harness technology, especially the Internet of Things, to address the multifaceted urban challenge proactively. As our poster objective states, we aim to investigate IoT's potential as a transformative tool for environmental sustainability and to explore how its integrating can shift urban management towards protective data-driven methodologies. Thank you.
Thank you, Saiteha. My name is Sebastian Romero Laguna, and I'm going to cover our solution, the IoT overview and application in cleaner air. Well, let's point out to the IAQM system architecture. So, what is our proposed solution? You may wonder. Um, at, at its heart, it's leveraging the Internet of Things, or of course IoT, as depicted in system architectures like this indoor air quality monitoring system that we have been pointing in at the middle in the center of the presentation, the, the IAQM image. IoT involves a network of interconnected devices. These devices embedded with sensors collect and exchange data, which is then analyzed. And with analyze, I mean that we can get insight from this raw data and thus improve efficiency. Now let's look at the specific application, enhancing air quality, which I have promised to you. Then, why does it matter? Well, this is one of our core objectives. If you look at IAQM image again, this is an example of sensor deployment. Urban air pollution is a major contributor to health issues, as Saitea mentioned before at the beginning of the presentation. Well, traditional air quality monitoring often relies on a few expensive, like small kind of houses, provisional stations that will read the air, and those are field stations providing limited spatial coverage. So IoT changes this. Why? Because if you can see at the first image at the left, probably at the right of the presentation, you can see one of the nodes, right? But with IoT, then you can go to the nodes, and I'm referring to the nodes as the clusters of sensors that then are interconnected, and they can be across the city. These sensors can measure pollution in real time. This data is transmitted wirelessly. That's why Wi-Fi is one of the icons, and it's present in the path from the nodes through all the way through the internet, because that's the way we gather the data. and that goes to a central platform. As our explanation section highlights, and it's just below the diagram, which pictures which depicts all the implementation, including the IoT, and how this one goes all the way through um, decision makers who can do something with this data. Well, this data fits into a core platform. Let's say it's in AWS or Azure, or as depicted in the report, another platform as a service. And and then it's processed using, let's say, deep learning, machine learning, which we have been learning in CQ University in different uh, topics like um, clusterization, k-means, and other. So don't want to go too deep in this, but this is a high resolution data that allow us to identify pollution hotspots and understand pollution patterns. This is all going through smart cities, so it's not about air only. It's about a smart city, which is a broader issue compared to the one that we will be depicting, or just in this case, just me, air quality. With this information, city authorities can implement targeted interventions, like going to the factories and saying, "Hey, why is this area um, like full of air pollution?" I'm going to be very quick in this. We have the data sources, which is air quality sensors, smart water meters, smart energy grids, traffic management systems, and other humanitarian crisis data like vulnerable populations. And those all goes to all the way down to a core platform as depicted in the diagram. Um, then we have foundational enablers, which are essentially decision makers, and we can find there the government and other authorities. And we can find cybersecurity and standards in regulations and other shared infrastructure like LoRaWAN or 5G or the cloud. Then it goes all the way down. It is ingested into a data ingestion storage. Then it goes and it's processed using advanced analytics, and then it goes down and it's enabled or enables a decision support automation. How can it be? Well, because it goes to improve air quality or water quality through, of course, decision makers who do something about it with the information. It goes to optimize resource management like energy waste or water, and also enhancing humanitarian response, because we can then governments can send, or entities, charity entities can send targeted aid and early warning to communities that are vulnerable. And proactive urban governance, which has been touched in the report, and planning. And then enhance citizen and well-being, which is overall what smart cities is all about, isn't it? Thank you, and I want to handle to Abu Taher. Thank you very much.
Thank you, Sebastian, for your wonderful presentation. Myself, Abu Tahir. My ID is 12285950. Now, I'm gonna talking about IoT for humanitarian aid and resource management. Beyond air quality, IoT offers powerful tools for managing other urban challenges, particularly in humanitarian aid and resource management, which are the key object of our research. To investigate the potential of Internet of Things technologies as a transformative tools for achieving environmental sustainability and enhancing human well-being in modern urban environments. To explore how to integration of IoT can facilitate a shift from reactive to proactive and data-driven methodologies in human management. To analyze the contribution of interconnected devices in and intelligent analytical systems to building resilient, efficient, and adequate urban ecosystem aligned with UN Sustainability Development Goal 11. To examine the specific applications and benefits of IoT in mitigation urban air pollution through real-life monitoring, predictive system, and policy evaluation. Our proposed architecture commonly signifies core platform or data processing, pointing to something central or fundamental which fits with the core data platform in our architecture. It is also conveys access, stuff, and interface. It could symbolize the decision support layer where outputs like alerts and visualization are presented to users. This usually represents controls, environment, and or support, matching well with the fundamental enablers like governance, cybersecurity, and infrastructure support. In crisis scenarios, this potential humanitarian data can be fed into the core platform. This enables improved situation awareness and resource allocation, crucial for effective humanitarian responses. I can give an example like IoT sensors can detect leak in water pipelines. IoT sensors in water pipelines continuously monitoring flow, pressure, and temperature. Alerts can be generated instantly for maintenance teams. This helps reduce water loss, save cost, and improve infrastructure efficiency. Thank you, sir. That's all from me. Now I'm handing over the presentation to Salman.
Thank you, Abu. I will be covering the conclusion and call to action parts. So, for these IoT solutions to be truly effective and ethically implemented, several foundational elements are crucial. As our poster's explanation highlights, these foundational enablers include robust governance, standardization for interoperability, strong cybersecurity and data privacy measures, and shared infrastructure like connectivity and cloud computing. Our research also emphasizes the importance of digital literacy and citizen-centric applications. In conclusion, the integration of IoT technologies offers a powerful means to tackle urban sustainability and well-being challenges. Through enhanced monitoring, like we've discussed for air quality, improved humanitarian aid capabilities, and optimized resource management, IoT provides a pathway to more resilient and livable cities. However, as our conclusion stresses, this necessitates a strategic approach. This approach must prioritize open platforms to avoid vendor lock-ins, develop citizen-centric applications that genuinely meet community needs, foster public, private, and community partnerships, establish robust ethical and security frameworks, and invest in digital literacy programs. By embracing these data-driven solutions proactively and responsibly, we can ensure effective, equitable, and sustainable urban development truly capable of addressing pressing issues like air quality and resource scarcity for everyone. Thank you.